All right, guys, welcome to the DMs. Today I'm going to discuss number systems. Number systems are something you may have never even heard of. Actually, we use the decimal number system, or base 10. I'm going to get into those number systems and how they work and the breakdown. And then I also want to discuss binary numbers, which are base 2 numbers. Binary numbers are those ones and zeros you see in like computer, graphics and things where you just see a bunch of ones and zeros. Those are binary numbers, or base 2 numbers. And then the numbers we use on a daily basis for monetary stuff, finances, the gas prices, the day of the week, the day of the month, I guess. That stuff is base 10 numbers, and I'm going to break down how those work and show you guys a little bit about what each place means and what each digit means. This isn't a particularly hot topic in high school or even college mathematics. It's actually pretty likely most of you have never even heard of number systems. But with our world continuing to get more and more technological and digital by the day, I think it's a good topic to cover, especially with the binary numbers, at least so you know what they are. And it'll give you a better understanding of numbers as a whole and why they are what they are. Plus, now the next time you see some clown walking around wearing a "there are only 10 types of people in the world" shirt, you'll be on the right side of a pretty cheesy joke. So now let's get into it. Alright, so let's talk about decimal numbers, or base 10 numbers. These are the numbers that you see on a daily basis. Every day when you go get gas or you look at the date, we're looking at decimal numbers, or base 10 numbers. So what do I mean by a base 10 number? So when we look at any number system, I should say, that number system has a base, and our base is 10. So if I look at a number in our base 10 system, let's look at the first 4 digits of any number. I think most people would be comfortable remembering that this is the ones place, this is the tens place, the hundreds place, and the thousands place. Well, what we're really looking at, because this is a base 10 number, is we're looking at a base number raised to a power. And this first place is the base number, so like I said, 10, raised to the 0 power. And that number is just 1. Let me just clarify that. Anything raised to the 0 power is 1, except 0 raised to the 0 power, because that's a special case, and like many of you may remember, anything raised to the 0 power is 1, but 0 has some special properties, so 0 raised to the 0 power is kind of undefined. But just take this as a fact for now, because we're going to need it throughout this video. If you want to look that up, there's a lot of YouTube videos on the reason why anything to the 0 power is 1, but for now just take it as a fact. So let's go into this. 10 to the 0 is 1, so that's where the ones place comes from, this 1 and this 1. The tens place comes from this next place being the 10 to the 1 power. 10 to the power 1 is just 10, right? I think everyone's comfortable with that. 10 squared is the next place, and that's 10 to the power 2, which is just 10 times 10, which gives us 100, and that's where we get our hundreds place. And then lastly, we have our thousands place, which if you didn't guess by now, that's 10 cubed, which is 10 times 10 times 10, which gives you 1,000, and this 1,000 is this 1,000. So if you were to keep going, it'd be 10 to the 4th, 10 to the 5th, blah, 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 all the way on, and then we'd be your 10,000s place, your 100,000s place, and so on. So if we look at a number, let's take a random number like, let's say 1,031. What that means is that we have 1,000, we have 0 hundreds, we have 3 tens, and we have 1 1. So if we wanted to break this down, we can say that it's 1,000 plus 3 tens, which would be 30, and then 1 1. 1,000 plus 30 plus 1 gives us 1,031. And that's exactly what base 10 numbers look like. A base 10 number broken up into its powers is a 1, 3 tens, and then 1,000. So for another example, let's take the number 35,316. This would be 3 10,000s, and then you have plus 5 1,000s, and then I'm going to run out of room here, but 3 hundreds, right? 110, and then 6 ones. So if you add those up, that's 30,000 plus 5,000 plus 300 plus 16, which gives me 35,316. And that's exactly what we would expect. So now I want to look at a different number system. You may have seen these numbers before, and that's called binary numbers. So binary numbers. So this is decimal. These are all decimal numbers up here. Or base 10. We're going to look at binary or base 2 numbers next. Binary or base 2 numbers follow the same pattern, except instead of the base being 10, the base is going to be 2. So instead of this being 10 to the power 0, this is going to be 2 to the power 0. This is going to be 2 to the power 1, 2 to the power 2, and 2 to the power 3. And since I'm running out of room, I'm just going to draw an equivalent one here. And I think we would agree that, like I said, anything to the power 0 is 1. So 2 to the power 0 is just our 1's place again. 2 to the power 1 is just the number 2, so that is our 2's place. 2 squared is 2 times 2, which will give us our 4's place. And then 2 cubed is 2 times 2 times 2, or 4 times 2, which gives us 8, and that's our 8's place. And so the thing that's different about binary numbers, as you may have seen before, is they're made up of only 1s and 0s. And you may wonder why are these numbers made up of only 1s and 0s? Why aren't there 3s or 4s or 9s in there? Well, the reason why you have digits 0 through 9 in the decimal system is because you could have up to 9 ones before it would make sense to say, instead of saying I have 10 ones, I'll just say I have 110. So if I'm looking at a number in decimal, I'm not going to say I have 10 ones. That wouldn't make any sense. I would just say I have 110 and then I have 0 ones, and then that's where our number 10 comes from. But in binary, we can say I have 1 1, and then instead of saying I have 2 ones, I would just say I have 1 2 and 0 ones. So the number 1 0 in binary is equal to the number 2 in the decimal system. And that's where the joke comes in. The 10 types of people in the world is actually the number 2 in decimal. So let's expand this. Let's go on to another page. So let's look at a binary number. 1 0 1 1 0. How about that? So I've got 5 digits here. 1 0 1 1 0. I'm going to look at the first place, which I know is my 1's place. The second is my 2's. The third is my 4's. The fourth is my 8's. And then this would be my 16's place. So if you haven't noticed, the place is just multiplying by 2, where in decimal, each next place multiplies by 10. This is the 1's. Multiply that by 10, you get 10's. Multiply that by 10, you get 100. Multiply that by 10, you get 1,000, and so on. It's the same thing for base 2, except with 2's. So if I take my 1's place, I multiply by 2. This is my 2's place. Double that, that's my 4's place. Double that, that's my 8's, my 16's, and so on. So the next one would be 32's, and then 64's, and so on down the list. So this number, if we were going to add it up, similar to what we did here, right? We said we had 1,000 plus 30 plus 1 because we had 1,000, we had 3 10s, and we had 1 1. Well, here we have, it's much easier actually. We have 1 16, we have 1 4, and then we have 1 2. So if we add those numbers, right, 2 plus 4 plus 16 gives me the number 22. So in binary, the number 10110 in base 2 is equal to the number 22 in base 10. Alright, so now you guys know a little bit about decimal numbers, which is base 10, and binary numbers, which is base 2. If you want more on this topic, leave a comment, and I will potentially make a supplementary video with harder examples, or if you want to know applications. Like, I just want to know, give me some feedback on this stuff, on these videos. Please let me know like what you want to see more of, what you want to see less of. And then if you check out the link in the description below, I've posted practice problems on the topic with solutions to those problems, so you can try the problems and see if you get the right answers. And I'm also posting a challenge problem that's not going to have a solution, and then I'll make a second video which answers the challenge problem. It's going to be me solving the challenge problem and explaining how to solve it. Basically, if you want to, you can try the challenge problem before you check out the solution to challenge yourself, and then you can get the solution from me in my video. And alright, I'll see you guys next time. Don't cheat.